The Recovery Potential Screening tool compares watersheds or hydrologic units to determine differences relevant to a stated purpose. But what's the math behind the scenes? This module covers the calculations in an RPS tool, including its handling of indicator values, its development of multimetric indices, and the principles of relative scoring. It's important to keep in mind that this tool generates simple indices for general screening level comparisons. It's not a robust model. It's a general comparative assessment tool. The basic math behind RPS was kept simple and flexible so that the tool could be customized by the user to be most relevant to the purpose and place at hand. Watershed indicators are the RPS tool's basic unit for quantifying and comparing. Despite their great variety, some common traits of good indicators include: they can be reasonably characterized as an ecological, stressor, or social parameter. They can be generalized as single numeric values per watershed or hydrologic unit. They have a consistent directionality of value, such as a higher score is always better. They can be measured over large areas, and value differences are potentially meaningful and helpful to planning and decisions. The raw values of single indicators are frequently used in the RPS tool to compare watersheds, but in order to use indicators in an index, the tool automatically adjusts its indicator values. Raw score ranges can differ by many orders of magnitude, and all need to be normalized to be used in the same index. This formula for normalizing adjusts each indicator's values so that the maximum value is set to 1.0. If differential weighting is also applied to each indicator, the normalization formula is adjusted with weighting included. This example of stressor index calculation shows what happens next as 5 indicators are combined to become a stressor index. For each watershed or HUC, there is a normalized value for each indicator. And in this example, weights have also been assigned. The weighted value from each indicator in the right column are the inputs. To the index formula, the sum of these inputs is divided by the sum of the weights and multiplied by 100 to yield an index with a range of 0 to 100. The same formula is applied to create the ecological index and the social index. A few other points about index calculation are worth noting. When a watershed has no data for a given indicator, its index score is calculated from all the remaining indicators. The minimum number of indicators is 1 in each of the 3 index categories, or the tool will not run. The maximum number the tool will accept in any category is 20 indicators. However, to minimize signal-to-noise problems, it is better to use fewer than that. 3 to 10 indicators per category is the recommended range. With indicators and indices, it's essential to understand directionality, or in other words, whether a higher score is better or worse. For all RPS ecological indicators and the ecological index, higher is better. The same is true for social indicators and the social index. In the stressor category, however, higher stressor scores logically are worse for watershed condition. The Recovery Potential Integrated Index, or RPI score, is a 4th multimetric index generated by the tool. It offers a combined score that equally weights the ecological, stressor, and social indices. The RPI score is merely a 4th index option, not meant to be the primary RPS product. Its directionality is higher is better, and its formula, like the other indices, yields scores between 0 and 100. Now that you've seen the math behind the scenes, let's talk about some very important principles of relative scoring. Please keep in mind that RPS was designed and constructed purely as a comparative assessment tool. It generates value gradients from highest to lowest, but does not pre-make judgment calls along those gradients about what the scores mean. That is the user's option and is case specific. It may be desirable for a user to identify threshold values for their specific screening purpose and place, but these decisions are not built into the tool in advance. Moreover, the value gradient for any screening reflects only the watershed subset included in that screening, not all the watersheds in the tool. A subset may be all in excellent condition, or in very degraded condition, or somewhere in between, but will still be arrayed from highest to lowest scores. Reference information of some sort is always essential to place a relative scoring gradient in context. Users may have their own reference site information or use the PHWA Watershed Health Index statewide or regional percentile scores found in the tool's ecological indicators. Another technique is comparing a subset's scores to the medians of all statewide scores, and that is covered in the bubble plots training videos.